Okay, here we go with section 7.6, similarity transformations. This section is really kind of a very definition heavy section. There's no theorems here, luckily, but it's a lot of stuff to define and go through. So even though there's not much to do and it looks short, it might take us a little bit of time. So we'll just see how this works out. And you may need to rewind a couple of times to pick up on things here or there. So here we go. We've already talked about congruence transformations. Those were reflections, rotations, and translations. And now we have a similarity transformation, which means it's not congruent, it's similar in size, which is called a dilation. Uh, so first of all, thing is to define. Um, Definition of dilation, copy down, transformation that enlarges or reduces the original figure proportionally. Okay, that's the definition of um, uh, dilation. The next part is similarity transformation. A similarity transformation produces a similar figure. So for the definition, similarity transformation produces a similar figure. Okay. Now, dilations. Okay, this is the tricky part. There are multiple things going on here. Um, there is a center of the dilation. The way that's drawn here, it's at point O. It's the origin in this drawing. Um, and what happens is basically you move a figure closer to the center of dilation or away from it, and that gives you your figure. So the question is identify the center of dilation of the drawing below. It's point O. Now, let me show you how this works, because this doesn't really give you a lot to look at. What you do to create a transformation that's a dilation is you take a point in space, call it point A, and then you draw rays through all of the vertices of a figure. So in this case, it's B, C, and D of this triangle here. So this is the original triangle, actually. I'll change the color. I don't know, let's make it blue. Make a blue triangle. So the original triangle is the blue one. The figure of the translation or the transformation, the dilation, is the kind of reddish orange one. Now, if I want to make it bigger, what happens is it travels along these three rays that go through point B, point C, and point D. And the further I go away from the original point, so right now I'm sitting close to A, I've gotten smaller. If I go away from A, I get bigger. Now, how much bigger? Well, that's the trick to a dilation. It's how far away is point C prime from A with respect to C. So for instance, C right now, from A to C, is 4.51 whatever in this figure. From A to C prime is 2.25. It's half as far away, so this figure here is half as big as this one. If I go twice as far away, the new triangle is twice as big as this guy. So notice that A to C is still 4.51, but A to C prime is 9.02, which is twice as much. So that's how it basically works in a dilation, and it's very, very weird, but this is the mathematical way to describe it. You don't just say make it twice as big. What you have to do is you have to pick a point on the figure, off the figure or somewhere, and go twice as far away to make it twice as big, or half as far away to make it half as big. And it gets to be confusing at times. So that's why we're not going to look at a lot of these examples on the video. We're going to look at a lot more of them in class. I just wanted to give you the basic rundown here. Okay, so the next few questions that you're going to have are really that you're going to stop with for the Zaption are going to be really questions about kind of definitions and stuff. So scale factor. Okay, this is very, very important for us. Scale factor is called K. Okay, that's the letter that's used for scale factor. So anytime you see him saying something about K, that means that's the letter we're talking about. So right down here it says the letter K usually represents the scale factor of a dilation. Okay, great. The scale factor of a dilation describes the extent of the dilation. Is it bigger or smaller? And here's the really important part. The scale factor is the ratio of the length on the image to a corresponding length on the pre-image. So this is what we're going to sort out in the next few slides. What does that mean? Well, the definition is image to pre-image. So first thing, pre-image, which one is that? So I'm going to have a question pop up. You tell me what you think it is. Okay. Hopefully you said the pre-image is the original figure, which is what it is. Okay. So pre-image is original. Now, next question. The image is the hopefully you said dilated figure. Okay. Now, the definition of scale factor is the ratio of what to what. That's what we're actually saying here. So we'll go back to that previous slide if you need to, or in the book, or make a guess if you couldn't remember. And then, yeah, see what your answer is. Hopefully you said the scale factor is the ratio of the length of the image to the pre-image. Okay. So now we have that. This is all the technical way they say it. There's kind of a more natural way. So here we go. Using all three of these guys together, here's answer for 4. Using the 3 statements above, another way to define scale factor is what? Dilated length over original length, or original length over dilated length? Hopefully you said dilated length over original length. Okay, that's what it basically is. Or another way to do it is this. New over old. That's another way to define scale factor. Okay. So a lot of times what people tend to miss is not solving for the missing side length in these guys. It's not finding a missing distance. It's the scale factor. People get those backwards, and you just have to memorize that it's pre-image to image, or it's image to pre-image. That's the definition. Image, pre-image. That can be confusing. It's really just the dilated to the original or the new to the old. Okay, now, next part. Types of dilations. If you need to, pause this. I'm going to go through and kind of, fill some things in for you here. So, the question is, define these. Well, the definition of enlargement is an image that is larger than the original figure. Okay, we've gotten bigger. Reduction, its definition is an image that is smaller than the original figure. And hopefully those are words you're familiar with enough already. You know what that means. It says range of k. That means the symbol. Basically means that if it's a enlargement, the range of k is bigger than 1. That means you've gotten larger. If you are reduction, your value is between 0 and 1. You can't get bigger. It can't be less than 0. It can't have a negative reduction. It's just either 0, which means it's gone down to nothing, or it's bigger than, or it's less than 1, which means it's smaller. And then the last part of that is, okay, copy the enlargement, copy the reduction below. Okay. So yeah, if you need to pause that, pause it, or if you got your book, just copy a little drawing out of there, just to kind of get an idea. Okay. All right, so here we go. Last couple examples then are just you figuring out, hey, given this drawing, is this an enlargement or reduction? And if so, what's the scale factor? Okay. So the order of this is that A is the original, B is the image. So A is the pre-image, B is the image. So the question is, how big is this or small is this? What is it? So let's go to the drawing. Okay. So using example 1 from page 512, answer the guided practice questions below. So again, A is the image, B is the, or say A is the pre-image, B is the image. Now hopefully looking at 1A, you can tell instantly, hey, this guy's gotten larger. I mean, I went from A to B, so this is an enlargement. Okay. The question is, what's the scale factor? So what we have to do is to find 2 sides that correspond, basically, for us, and then compare them. And the easiest ones to do that with, if you can't tell, are the 2 vertical sides, A here and B here. This side length here for A is 4. The side for B is 5. Now again, B is the new side, A is the old side, so the scale factor is new over original 5 to 4. Okay. Now, what I'm going to have next happen then is for this last one, I have the little guy pop up telling you, hey, I need you to work this out on your own and tell me if it's an enlargement or reduction, and then is it, if it is, what's the scale factor. So these are just little cues I use to remind myself. Click that. There, it fades out. Okay, so let's take a look at this. So 1b. First of all, hopefully you said this is a reduction. Not only because of the fact that I already did an enlargement, but because b is clearly smaller than a, and again, a is the original figure. So original, it's gotten smaller, so reduction. Okay. The next question then becomes, what's the scale factor? Well, again, what you need to do is compare two sides you can easily find the lengths of, and really the two vertical and horizontal sides are pretty easy to do. Let's just do the horizontal for the sake of being different from the last one. This guy's 3, this guy's 1. Okay. So this is 3 for the original length, 1 for the old length, or for the new length. Now remember, scale factor is new over old, image over pre-image, original over, or dilated over original. So it is 1/3. That's our scale factor. Okay. All right. So tomorrow then we'll come into class. We will go over some problems, look through some stuff. Hopefully again you make sense of some of the drawing. If not, come in. I will be more than willing to help you clear some of this stuff up. All right. Thanks.